We're moving right along here on different ways that you can solve a system of equations. Now we have two methods down, our graphing method and our substitution method. The third method is called elimination. It's also sometimes called linear combination. I wrote down both so you'd be familiar with them, but I usually call it elimination. This is my personal favorite way to solve a system, and if I'm going to do it by hand, 9 times out of 10, this is the way I choose to do that. On a quiz, I might specify you have to try like one problem each way to prove you understand the methods, but then for most of them, you're going to get to choose whichever method you like. But it's good to be familiar with them all before you make your decision. And I didn't write down steps on this first slide here because I want to do an example and explain why it works first. So, I'm going to draw a red box around the left side of the top equation and around the right side. Those two pieces in red are equal to each other. It says so right here. So that red box and that red box are the exact same thing. Okay? I'm going to draw a blue box around this part right here and around this part right here as well. Again, equal sign right there. That says that the two blue boxes are equal to each other. They're the same thing. So what I'm going to do right now, if the reds are the same and the blues are the same, if I took one of each, maybe I grabbed these two over here and I grabbed these two over here, the pieces in my hands must be the same as well. I mean, if it doesn't matter which red you take, if it doesn't matter which blue you take, if you grab one of each, you still have the same thing. Basically, that's just a drawn out way of saying if we add this left sides together and we add the right sides together, it's still going to be the same. We are going to add going straight down. And we're allowed to do that because the pieces are equal. So let me show you what happens when we do that. When I say add going straight down, first of all, make sure your variables are lined up like they are in our problem. I'm going to add the x's together. 2x plus 3x makes a 5x. 4y plus negative 4y, those just cancel. Equals, keep the equal sign in place, 22 plus negative 17 is 5. I added going straight down, and my brown equation right here is something that's very easy to solve. It was nice because when I added these, the y's just kind of went away. They canceled each other. So I'm going to solve that and get x equals 1. I just got my x a lot faster than either of the other methods we've seen so far. So once you have your x right here, just like before, you have to plug it in somewhere and get y. So I can either plug it in this equation or this one. It doesn't particularly matter. I'm going to take it and plug it in the top equation though. Of 2 times 1 plus 4y equals 22, and you just solve that. You get 4y equals 20. I end up getting y equals 5. So my answer is 1, 5. And as you saw, that was a lot faster and a lot less writing than the other methods we've experienced so far. So I went ahead and wrote down the steps for this method here, and I put one more example here. I'm trying to not to make the steps too crazy. Make sure a variable will cancel, which we'll talk about. Just add going straight down, and then solve your equation. So another example right here. Again, I could do any number of methods to solve this system, but I'm going to do my elimination method. So if I add going straight down, negative 5x plus 5x, that cancels out. Negative 2y plus 6y, negative 2 plus 6 is positive 4, so I get 4y. Equals 8 plus 36 is 44. I solve that and I get y equals 11. The only thing I have to do now is plug that back in somewhere and get x. I'll plug it in the bottom equation this time. There's no negative signs there, so it might be a little bit easier, but it doesn't matter. I get 5x plus 6 times 11 equals 36. That's going to be a 66. So when you subtract that, you get 5x equals negative 30. And if you solve that, you get x equals negative 6. So my answer to this problem is negative 6, 11. So at this point, you should be asking yourself, wow, this looks really quick and easy and it doesn't seem too bad. But what happens if your variables don't cancel? Like we added those and it was like, oh wow, the y's went away, or ooh, great, x's are gone. But as you guys hopefully can see, that won't always be the case. In the next video, we're going to learn how to handle situations where they don't cancel right off the bats.